Hi, good afternoon. I hope you have a nice lunch break. Like Asian people, we all like eat a lot of rice and carbon, so it it consumes a lot of oxygen to digest. And I hope you can still keep up. Maybe you can have some coffee. So this morning we discussed the scope. We discussed how to set the cap, and the next important topic actually matters to the cover entity is how to allocate this allowance to them. Yeah, so we set a cap, we have the limit of emission, and then it's also important for us to design the method to allocate to the company. So we will talk about different methods to do the allocation and understand why we choose this method, like free allocation, understand the treatment to maintain the special case like new entries or company close or removes, and how to set auctions in the long run to really give the price signal to the market. Yeah, so here are first of all, let's talk about some key concepts. We have the cap. First of all, we have the cap for the ETS that limits the number of emission and create the allowance. And then the scarcity of allowance create the economic value, and that the scarcity really create the carbon price. Like there's a limit and there is a trade. So we need to create allowance, establish an asset and allocate in some way. Then this method is the key how companies they react to ETS. Yeah, so we talk about scope, we talk about cap, but actually each company when they react to ETS is based on how much allowance they can get and how they can get the allowance. So yeah, this is a further level down to the implementation. So first of all, we will talk about why some icons are missing. So when we discuss allocation, we need to think about some policy objectives. Through allocation, we want to achieve some goals. The first is to provide incentives for cost-efficient abatement. We want the cover entities with lower costs. They can abate, they can reduce more than high-cost emitters. So we can reduce the whole society cost for greenhouse gas emission reduction. So that's the first goal. We encourage the cost-efficient abatement. And the second goal is to manage transition to an ETS. Like we have no ETS now, and we will have an ETS. And this transition, we have a lot of challenges, and we want to solve these challenges through some allocation method. And the third one is to reduce the risk of carbon leakage. Yeah, we already talked CBAM this morning, so we're familiar with that. And we also want to raise revenue for the government and invest in other low carbon area, help low carbon transition. And also through allocation, through trading, we want to support the price discovery, find out what is the appropriate carbon price for the market. So first of all, we think about how to reduce the risk of the risk of carbon leakage. And so there are different types of abatement incentives. And first, we want to encourage the substitution from high to low carbon producers. We incentive firms to reduce emission intensity, and we promote demand side abatement. So if we want to achieve that objective, the easiest way is to do it with auctioning, because only with auctioning that the companies, they can get the pressure. They need to pay each ton of CO2 emission, so that really increase their costs, and then they need to think about, oh, how should I deal with it? Should I keep paying that cost, or should I reduce by myself? So we need a real cost to the company to incentive their abatement. But of course, that can also cause some leakage problem. Oh, I think this the title is a bit wrong between two slides, but yeah, that the previous one I was talking about how to give the incentive. We need a real cost, and auctioning can provide this real cost, real pressure. But in the meanwhile, they will feel it will harm their competitiveness. In the previous phase, we didn't observe a lot of real carbon leakage. Like the industry always say, oh, you charge us more, then we will relocate to other countries. But that didn't happen a lot, or that didn't happen as we expected. They relocate because of other reasons, of labor costs, of energy costs. Carbon costs was too little to become the main driver of their relocation. But now we see the EU ETS price is very high, and EU is canceling the free allocation for industrial sectors. So with that expectation, the carbon leakage risk is going up. So even though there were little evidence of carbon leakage, but there's still potential undesired outcomes of carbon leakage, and will harm the environment, will harm the local economic, and will bring political challenges. So we still want to reduce this risk through allocation method. So that's the second objective. And the third objective is to manage transit to an ETS in early phase. Yes, when we don't have ETS, those companies, they already invest a lot in fossil fuel based industry, and then they have a lot of stranded assets is already there, and some of them, they have early action, early investment in emission reduction, and as policymaker, we want to award their early action. And there are some undesired impacts on consumers. The price may raise, so we also want to manage all these concerns. So at the very beginning, free allocation could be easier. Could be easier to accept, to be accepted by the stakeholders to compensate their stranded asset, and auctioning and early days for grandparenting benchmark can reward early action, and free allocation or revenue recycling can minimize the impacts of consumer concerns. So we also discussed a little bit yesterday. Yeah, so there's some concern, and we want to use the allocation methods to maintain these concerns. And then we also want to raise some revenue for the for the government, and then the government can use this revenue to accelerate the low carbon transition. We can use this revenue to support low carbon investment, some new technology, and other climate actions like climate adaptation, for example, also, and also some to support some financial financial assistance to more vulnerable poor groups. Yeah, some social fair projects, and all this revenue can also help go into the public budget to help the government just run it better. So there's also one objective from the allocation. And we also want to use allocation to support to discover the true carbon price. So when we say what is the right price for carbon, every government wants to know when we start the ETS, what should be the right price. And actually no one knows what is the right price. Only through trading, only through auctioning, that people can compare the market price with their own price. And after several rounds, negotiation, bidding, gaming, then they finally agree on some certain level of carbon price, reflecting the current ambitious level and the current abatement cost. Yeah, like even we may think, oh, for power sector, we think if we reduce fossil fuel power generation, increase renewable energy, what is the total cost for the power sector? But when we go down to each company, each power generator is different. Yeah, so in the short term, the policy goal may be increase their efficiency. And some power company, they may have very poor management, so they can only invest little money, improve their management, and they can achieve big amount of reduction. But some power company, they already have very good management, and they need to replace a generator, upgrade a generator, invest a big amount of money to do a little reduction. So each single installation is different. We cannot decide a market price for them. This price must be based on their actual market trading behavior. They compare their own price to the market price, and then through the trading, the whole market will reach the price. So free allocation and small market size may not achieve this market price, and we actually need auctioning to encourage everyone to compare their price. So there's several objectives we want to achieve through auctioning, and what kind of method we can use. I don't know why these stocks are there, so I'm sorry. It doesn't show in my slides in my computer. But anyway, so here, allowance. So government, when they set a cap, for example, 100 million cap, 100 million tons cap can create 100 million allowance. And then the government needs to give this allowance to the company. And there are two major ways. One is government give them for free, and the other one is government sold to the company. The sold could be auctioning or with a fixed price. And for free allocation, it could be based on their historical emission, or you can base on benchmark, like product level benchmark. So there are two major ways to give free or with price and show to them. So for the method that the government sells allowance to the company, we mainly talk about auctioning here. So auctioning is theoretically, from economic theory, is the best way to allocate resource. Yeah. Again, all this information you can find in the ICAP World Bank ETS handbook, and also the slides you will get the slides later. Maybe I can use another example. So if the government wants to develop an area in the city, do they sell the earth, the right to build, to develop the earth? Do they sell this right to the developers? So in China, when the government wants to develop area in the city, they will put this whole land to auction. Different developers, they come to bid for the land, and then the highest bidder, they get the land. So it's the same, is the limited resource, and how to give a price to the limited resource. The best way is to auction. Let everyone, they have their own idea, they have their own costs inside their mind, so they will have the best price offered to the government, and those who can pay for the highest price can get this resource. That's the best way to allocate limited resource. So that works for land, and that also works for carbon emission. It's also a limited resource now. So theoretically, that's the best way to reflect the resource, the value of resource, and to raise the public awareness. Let the stakeholder actually pay for it, and it's easier. The government don't need to negotiate with the industry, right? You just come and bid. I don't need to negotiate with each sector, each company, how many I should give it to you. But for free allocation, the company will come to lobby. Yeah, so that's one advantage. And it also reward early action. So the company, if they already did a lot of early investment in reduction, so they only bid less than their competitor. So it also reward the early action, and find the good price for the market, as I said, and generate revenue for the government. So it meets almost all the targets I mentioned, but only one target cannot meet with auction, is the transition to the new market. So when it's difficult for the industry to give that amount of money to the government at the very beginning. Right now, especially right now, the global economic is not doing well. The industry, they are losing money. And at this time, you ask them to pay 5%, 10% more of their cost to the government only for carbon. Yeah, it's very difficult for them to do it. First of all, they need to understand climate change, and then they need to understand carbon market, and then they need to understand MLV, they need to understand trading, and all of this, and then they will negotiate the competitiveness laws. So at the very beginning, it's very difficult to have auction, especially when the industry are not doing well. So that's the only disadvantage of auctioning. But a lot of markets are already using auction to allocate the allowance. In 2025, all the carbon markets in the world, they raise $80 billion from auctioning. And from 2007, there are more than $450 billion raised from auctioning. And of course, most of them are from European countries, EU ETS, Germany ETS, UK ETS, and then California ETS. So these carbon markets, they raise a lot of revenue from auctioning, and that means the cover entities in this ETS actually pay that amount of money. So when we say we increase the carbon costs from carbon pricing mechanism or from carbon market, that's how much carbon market increase the cost. Yeah. Of course, secondary market trading between different stakeholders, it also creates some incentive, but the major driver is auctioning. Yeah. And through auctioning, the jurisdictions can use in different ways, like we already talked about Austria, California, Germany yesterday. How do they use this revenue to compensate the rise of energy price? And of course, they can also use this revenue to invest in low carbon technology. So yeah, this also very good for the government to promote low carbon technology and transition. So that was auctioning, and the other method is free allocation. Like I said, free allocation can help the whole industry or the whole society smoothly transfer to ETS, especially at the very beginning. So we see a lot of new ETS, even EU ETS at the first and second phase, was mainly using the free allocation. And there are three major ways to use free allocation. One is grandparenting. It basically allocate the allowance based on the historical emission. How much you emit in the past, how much you will get now. Of course, there's some maybe reduction, but yeah, you compare to your historical data. Yeah, you don't need to compare with other company. You don't need to compare with other sectors. You only compare to yourself. So that's easy to implement. That's very attractive for cover entities. Yeah, because it's related to their previous behavior, and they only need to work based on their own situation. And it's simple for the government, no need to develop benchmark or other method. Yeah, and it still maintains some abatement incentives. So if they reduce their emission, they can sell the allowance, and the government can also decide a reduction rate to give them the pressure. But it doesn't avoid the early action, because everyone compared to themselves. If you already did a lot of reduction previously, then it's very difficult for you to reduce the same percentage now. Yeah, like I said, if those who already have very good maintenance management invest a lot of renewable energy efficiency projects, they will have more expensive way to reduce the same percentage. So it doesn't encourage the early action, and it may introduce the distortions and gaming, like win for profit, like we saw in the EU ETS. So in the EU ETS at the very beginning, all the power company, they have free allowance based on their historical emission, but in the same time, they also tell their customer they need to pay for the carbon now. So they have free allocation, but they increase the electricity price, and then they just gain some money. Yeah, so that cannot provide enough incentives, and that will also have barrier for new entrants. They don't have historical emissions. So yeah, so that's the advantage and disadvantage for grandparenting free allocation. So another maybe better way to do free allocation is to use benchmark with fixed historical output. So it also based on the history data, but history production data, and then times the benchmark. So it means the company compare with the company in the same sector, and then the company who's doing better, then they can receive more allowance. That gives the incentives for early action. They give the incentive to the company to improve their efficiency. And so compared to grandfathering, it's better to award those who actually doing good in emission reduction. But also it has this disadvantage. It needs a lot of data to develop benchmark. So for example, maybe power is easier. You only have one product, electricity. But for chemical, one chemical factory may have 2, 3, or even more products. And it's very difficult to define the benchmark for each product. So for steel, for chemical, petrochemical, it requires more data, more monitoring, more verification to get the data and develop the benchmark. And so it's also free allocation, so it also reduces the payment incentive. It's also free allocation, so it also has the risk of windfall profit, and it has mixed results in mitigating leakage risk. So in general, you can still reduce the leakage risk. Is again free allocation, but some company may also suffer from it, and it provides the potential for lobbying. Like how to define the production, how to set up the benchmark. There are a lot of space for industrial sector to lobby. So that's the benchmark for fixed output. And right now, we have benchmarks with output based. So it is also more flexible. It means the government only controls the intensity. That if the company, they like I said in the morning, the company, they produce more, they can get more allowance. It doesn't limit their output. And so the intensity, it has the incentive to reduce the intensity, and it strongly targeted leakage risk because it's output based. It's not based on the historical production. So that can actually reduce the leakage risk. And it's also attractive for new entrants because they don't need to buy additional allowance. They just get allowance based on their production. So it doesn't matter you are old or new in the market. But it has strong incentive to maintain and increase production level. So if you are doing well in the company, if your intensity is low, you are doing well in carbon market, then you have the incentive to produce more, even more, and you can earn more allowance. That's not good at all for climate purpose. And also it requires a lot of data, even output data, and it has the potential for lobbying. And it's so difficult to estimate the cap because it's every new year we have new output, then there's no way that we can have a long-term cap with output-based allocation. So here are the summary. In this table, we see the auctioning is relatively good. It has the strongest incentive for cost-effective abatement, green, and you can raise revenue, green. It can help to discover the price, green, and it's not very good in managing transition to a new ETS. It's not very good to reduce the carbon leakage, but in general, I think auctioning is better than free allocation. And that's why we see a lot of system, even though they have intensity-based cap, they still want to transfer to absolute cap, and they still want to. And then when they start with free allocation, they will say, oh, we will introduce auctioning, and we will maybe start with a smaller percentage, and then to increase the percentage of auctioning, like EU, what EU is doing now. So EU, in the first and second phase, EU has very little percentage of auctioning in some member states. But yeah, in general, it's free allocation. But from the third phase, EU start to have auctioning in power sector, because power sector doesn't have that much leakage risk. Yeah, power needs to be there. You cannot relocate to other country. So we start with power, and now EU is reducing the free allocation in industrial sectors. So that's how you do it. And China will introduce auctioning, I think, later this year or early next year. So yeah, in general, we can see the trend that started with free allocation and then transit to auctioning. And here's a summary. So in some carbon markets like Austria, Germany, RGGI is the carbon market in United States and Massachusetts. So some carbon markets, they have 100% auctioning, no free allocation at all. And and the other carbon market, they have mixed methods. Some of them, they have no auctioning, 100% free allocation with grandfathering or benchmark. And some carbon market, they have mixed with auctioning and free allocation. Yeah, so you can also go to the ICAO website. We have more information there. And there are some common challenge I already mentioned, so I will not go into details, how to mitigate the carbon leakage risk and how to deal with the new entrants and closers when a new company come into the market. Do they need to buy 100% of their allowance, or you give them some free allowance? That also provide different incentives. And when they close the company, how to deal with the surplus allowance? Do they need to sell them, and can the government get it from the company? So it also requires some rules that are predefined. So there are different options, like setting up new entrants reserve, or there are auctioning and output-based allocation methods only for this special situation. Yeah, so there are different ways to do it, but we, as a government, we need to think this special issue before or when we develop the allocation method. Okay, that's the major contents I shared today, and we can discuss these topics during the break to see what are the options for Thailand ETS. For these 5 policy objectives, what is the major one right now, and what is the major challenges we have? How to use auctioning or free allocation to deal with these challenges. Yeah, thank you very much, and welcome to see our handbook again. Yeah.
Okay, so it's question and answer time. Please.
One question, Sibin. You share us that some country only allow auction, no free allocation. And Professor Thongchai yesterday on his UNDP paid study also proposed that auctioning should come earlier. I'm wondering on the economic report like GDP from these countries, because they already implemented for many years. So how does the GDP grow or reduce, something like this? Because from Professor Thongcha yesterday study, sectoral economic CTE study showed that it picked up very fast. So we just want to learn the real case from these countries.
Yes, I don't have the research data, but like Germany and Austria ETS start in 2021, right? 21? Yeah, yeah. So they didn't run for a long time. Yeah, they only, so Germany and Austria, they start to ask it's not trading, but they have a fixed price. It's not auctioning. They have the fixed price that all the emitters, they need to pay 100% with that fixed price. But it also, it covers some part of the emission. Another big part is still covered by EU ETS. Yeah, so it's very difficult to say the national ETS, what is the impact to the whole GDP, because it's not the same scale. But as Andreas mentioned yesterday, right now the Austrian citizens, they pay for the carbon price and they don't get the compensation anymore, and they didn't complain that much. So yeah, I think that explains something. And still, when you put, well, we see each ton is 40, 50 euros per ton CO2, but when you just put it into each gallon of gas or each kilogram of oil, it is not that significant. So yeah, so I would say so far it runs well and people can accept that. Yeah.
I have one question on this issue. Is there any country that start, except for Austria and Germany, because they are part of the EU, like Letty and Massachusetts, do they start at the beginning at 100% auction since the beginning, or it's like increasing up? Do you know that?
Yeah, if I remember correctly, Reggie starts 100% auctioning at the very beginning. It only covered the power sector in 9-10 states in the US. Yeah, only power sector. So, but it starts 100% auctioning. And in California ETS, also for the power sector, it started 100% auctioning for the power sector in California. Yeah.
So it seems that for the power sector.
Yeah, because power sector, the leakage risk is very low.
Yes.
Yeah.
มีคำถามอื่นไหมครับ
So maybe to add two things. So we have full auctioning in the power sector, yes, and the leakage risk, it's differentiated because the electricity that is consumed by industry leads to higher costs in industry if electricity carries the carbon price. That's why we compensate it afterwards with an electricity price compensation. So there I would add that you have a leakage risk through the carbon costs incurred on the electricity price. That's maybe the first thing. And then the second thing is the reality of free allocation in the power sector is also a more complex one once you look closer at it, because Germany is or the EU is a region where you have very cold winters, and we have a lot of combined heat power plants. So in this, you need to split then between electricity production and heat production. It's the same plant. And then historically we had a free allocation for the heat share, but auctioning for electricity. So in reality, we had it this morning as the entry question. The ETS is never simple, but that's catering many demands of industry, of private households, etc. And that's how such more complex rules come into being.
Okay, I think we can have a round of applause for Mr. Sibin, and then thank you. Next, we are going to the online guest. I think Irini is already ready.
Hello, everyone. I'm trying to upload my... Can you hear me?
Yes.
Excellent. Hello, everybody. I'm trying to upload my presentation.
Okay, so Irini is gonna talk about the experience of the EU on the allowance allocation. So it's gonna be a good exercise because the case of EU is quite complicated and it have lasted a long time through several phases. So there should be a lot to learn.
Thank you very much. For me, at this moment, the most complicated issue is to upload my presentation. I don't know what you can see. Can you see the presentation?
Yes.
Okay. And I'm afraid that if I put it in slideshow, then I don't see anything from, I didn't manage to have my presentation and you in my screen. So please, if you want to ask something, if something is wrong, you need to interrupt me. You need to just say it because I don't see any flags, any chat, anything. Okay?
Okay. We'll let you know, but we can see the presentation perfectly.
Yeah. Excellent, Colin. Thank you very much. So hello again. I feel a bit sad because I'm not there with you. So I'm not. I know the program. I have seen what it will be about, but it is different to see the presentations of the other presenters and understand where the gaps there are, where you can contribute more. But I'm here, so if something is a bit too much for you today, or if it is there is a gap and you would like to hear more, please just let me know, flag it, and I can perhaps fill the gap today or on a Friday. So designing the Go ETS fixtures, it's not an easy thing. It is something that I would like to stress because I think that you may have not heard this before in this seminar, in this training. I would like to start with the institutional setup because it is very important to see that a system must have very well defined boundaries, roles, responsibilities, and this is what the EU ETS, I'm going to talk about this, defines. It is important for an ETS when you started to have something like this. We have learned it after so many years of implementation of an ETS. It didn't start like this from the very beginning, the EU ETS. It defined the very essential things and then it was developed. So the institutional setup of an ETS defines the scope, of course, the scope of application, which installations emitters are in, which are out, the activities and the greenhouse gases that they are covered, the participating entities that they are subject to obligations under the system, the obligations of those entities, and then the allocation modalities, including provisions on free allocation where applicable, if there is free allocation in a sector. The monitoring, reporting, verification, and accreditation, I should say here, requirements for emissions, the registry arrangements and procedures for the issuance of allowances, holding, transfer, cancellation of allowances, the compliance cycle, including surrender obligations and deadlines, the enforcement provisions, including administrative penalties and measures applicable in cases of non-compliance. So all these things there should be defined in an ETS in order to run smoothly, in order to have a robust system. So, in other words, the system establishes the scope, the system sets the union-wide cap of on the total quantity of allowances. Why? Because you need to give free allocation, and in order to give free allocation or to have some part of auctioning, you need to have a cap. This is how we approached it. It determines the distribution of allowances, the rules how we are going to distribute these to each installation. And the EU ETS does not define individual emission limit per installation. This is something very essential that we have to keep in mind, that the EU ETS does not define a limit on the emissions of an installation. An installation under the scope can emit as much as they want, but requires its operator to surrender allowances corresponding to its verified emissions. It provides for the annual reduction of the cap in line with the applicable linear reduction factor, and it lays down rules on free allocation, registry operation, auctioning, and the trading of allowances. This morning you discussed about scope and coverage. In general, I suppose I would like to say only a few words, it won't take long, about the EU ETS scope and coverage. It covers the large stationary sources, the installations, we call them. In other countries, I can see that they call them facilities, or in other countries, they consider the entities of their ETS the companies. We consider in the ETS for stationary installations, the installation as an entity. It covers power and heat generation and energy-intensive industry. It started in 2005. Now, in 2012, started to cover emissions from aviation. So we have also aircraft operators as an entity in our registry. Now it covers maritime shipping companies for covered voyages, and the scope expanded to maritime in 2024. The entities in the registry, they are about 12,000. In 2024, the electricity, heat, and industry installations were about 8,704. And there we have categories. When you talk in the next presentations about MRV, you will see that in EU ETS we classify the installations depending on how many emissions they emit in average every year. So there is a category A, which is the 71% of the installations. That means that they emit until 50,000 tons per year. The category B, that they are 22% of the installations under the scope that emit between 50,000 and 500,000 tons, and the very big emitters, which is only the 6%, category C, and emit more than 500,000 tons. So we can see less installations emit a lot. We have aircraft operators, they are 393, and shipping companies 3,313, quite many. There are some, I put here some numbers so you can see the emissions in 2024, for example, but this is just for your information. I must say that the EU ETS is primarily composed of the power sector and energy intensive industry. Aviation was included, but as a smaller but established sector, it is there. In aviation, we do not have a cap. Maritime transport constitutes significant new addition, and municipal solid waste is already under the MRV, and it is considered for inclusion under the scope for compliance. We'll see in 2028. I added that slide just because of the previous question that what about the GDP growth if we have an ETS? Well, this represents for the EU ETS the whole EU GDP, and here you can see that we managed to have a GDP growth while we have reductions in total emissions. Just for display, it is something for you to keep in mind. I suppose that the individual states that they run their own system, they might not have already results, but this is what it happens at the EU level. So, and after that, I would like to talk a little bit in practice about the scope that you have already discussed in the morning. But I'm not sure if you have talked. Colm, please, you need to you need to interrupt me if you have talked about this. That I'm going to present now. It is the legal basis for the scope of the EU ETS, which is, of course, the ETS directive, the Bible, as we call it for our ETS, and it defines the scope in this article and in the annexes. And the scope it defines exactly the specific activities as well as the greenhouse gases, which are apart from the carbon dioxide. You can see methane, nitrous oxide, etc. I would like to give some examples of activities that they are under the scope. For example, we do not have under the scope of ETS the activity production of electricity. This does not exist. There may be an installation that produces electricity, but it is not under the EU ETS. Why? Because the capacity of this installation is lower than 20 megawatt rated thermal input. So in EU ETS, we started the system only with the big emitters, because it was, when it started 20, more than 20 years ago, it was just a burden for everybody. Nobody wanted to hear, even to hear about this. Industry and power sector were very against, of course, and they were okay only when they heard that they are going to get free allocation of allowances that they need to surrender. And then they started to understand that if they are early movers, then they might have actually a benefit. So we did not want to include installations that they are not really emitters, big emitters. So electricity, the heat generation is there for any purpose if the installation exceeds 20 megawatt in capacity. And the engineers, they know very well the capacity of an installation. Another example, it would be the refining of oil, where combustion units with the total rated thermal input exceeds again 20 megawatt. If it is small, there are not many smaller, but if then it is not covered by the system. However, the production of coke, for example, there is no capacity limit there. Production of coke is there no matter if it is a big installation or a small, because of its intensity to emit. And then there are some other examples for primary aluminium or alumina, for cement clinker, that of course also there is a production capacity. For the manufacture of glass, it's exceeding 20 tons per day, etc., etc. And you can see the greenhouse gases that we are considering in our monitoring and reporting of these of the emissions of these installations. And I would like to note the production of nitric acid. For example, it does not concern only carbon dioxide, but also nitrous oxide. So those were some examples of the activities that they are covered under the EU ETS, and here is the whole list that was produced from an old colleague, Robert Gemil, and we recently had a presentation from him in a study tour here in Brussels. So I asked and I present here. You can see, just for your reference and just for your information, all the activities that they are under the scope of ETS. After the definition of the scope, that means which installations they are under and which they are not, the operators of the installations must go to the what we call competent authority in a ministry, the service that each state has appointed as a competent authority, and they must go there to submit their monitoring plans together with application to receive a permit. So permitting is an important step, which is before everything it runs for an operator. It means for an operator to be under the ETS. And I would like to say a few words about the cap setting. I know from the program and from Colin that you discussed about cap setting in the morning. For the EU ETS, I would like to give you here an example so you have it in the presentation, and later if you have any question you can visit again it and read if you have questions, etc. It was usually when we present the cap setting, we are very theoretical. On the way up, we get in some ways they say, we should establish the MRV first, receive the data, and from the installations that there will be under the sector, under the scope of our ETS, and then we will define the cap. Well, in the case of EU, this did not happen. The cap was estimated. It was a bottom-up approach, but it didn't happen exactly with the same way with concrete MRV rules that were there for all the installations. And after gathering the super data, we established the cap. Yes, it was a bottom-up approach, but it didn't happen in that way. The member states submitted national allocation plans to the Commission for approval. The Commission required amendments, tried to understand if they were exaggerating, because everybody, of course, every member state wanted to have more allowances available there for distribution for their industry. They said we haven't reached the peak, we are still developing, we were not there historically, our responsibilities are not so high, etc. So you can understand that there was a lot of a very good mixture of data, assumptions, modeling, projections, and a lot of political discussion there, as you can understand. And then the cap was set up when its national allocation plan was approved by a Commission decision. Then the total number was the cap, the EU cap. And here I have a couple of slides to explain how the cap was determined. what it meant, what it means to determine a cap now. Now there is no Kyoto Protocol. In our case, we had the Kyoto Protocol targets. Now we have the NTC's targets. Can a cap change or not? Should be absolute or not? In our case, yes, we believe that it should be absolute. Because if you do not have a target, a number in your mind, I mean, as a country, then it is not easy to define your, to distribute your targets to sectors, etc., and to define your policies and measures. Main lessons learned from the EU ETS cap setting. Well, it was a combination of Kyoto obligations, historical emissions, economic growth projections, technological potential, and political negotiation. I think I said all these before. The biggest challenges were uncertainty in emissions projections, data quality, the benchmark calculation, and balancing ambition with industrial competitiveness. So here I presented an example of one country that I found the national allocation plan. And there we can see that this country, Greece, actually was allowed to increase emissions by up to 25% above 1990 levels, while there were countries, member states, that they had to decrease emissions based on above the 1990 levels. Here we have an example that it was also good because for developing countries, you feel that you need to increase more your emissions because they say, we haven't reached the peak. So here it is an example like this, but the ultimate goal must be an absolute thing at some point that must be reached. So with the business as usual projections were plus 38%, and then the ETS cap had to be set below projected emissions to close the gap. And then there was stakeholder consultation that was a critical part of the process, etc. I will not go through this because Colm told me that you discussed about scope, about cap setting, so I wouldn't like to take up of your time more on this, but it is an example there for you to just to read. Yes, and here it is just a presentation of the EU cap, EU ETS cap, that it started from 2.3 billion in 2005, and it goes down following a linear reduction factor that it is defined by law. So politically, we agree that the target will be by 2020, for example. When we started this exercise, we had a target in 2009. We had the decision that said that by 2020, we'll have 20% reduction of emissions compared to 1990 levels. And it was called the triple 20. There was a condition also that if there are certain conditions internationally, then we'll try to achieve 30% by 2020. And the truth is that the fact is that EU had 31% reduction by 2020, so exceeded the scope without international conditions favorable. And here you can see the reduction of the cap. As I said, it follows the law. It is the linear reduction factor. That means that we have less allowances to allocate, either free or by auctioning. And I don't know if you have any questions so far, but then I can go to the allocation and talk a little bit more, continue like what the presentation of Zipin, that and go on more concrete examples on allocation under the EU ETS. Can I continue, Colm? I cannot see you.
Let me just ask the room if there's any questions or comments before we go into the last bit. No, Surum all shaking her head. No, I think we're okay. We have about 15, 20 minutes left, if that's okay, Rini.
Yes, 15 minutes is perfect.
Thank you.
Thanks. So I continue. In ETS, we started from the beginning, 2005. The auctioning was possible, but it was independently could start independently from the member states. There was no union registry. After the definition of the cap, we had the distribution of allowances to the member states. Then each member state could distribute the total amount of allowances to the incumbent installations, to the existing installations under the scope, or and that was the wise thing to do, they should keep one part of the allowances to distribute for the new entrants. That means the installations that they were entering, that they would enter the ETS later. There was an example of a member state that part was significantly low, and then there were new entrants that they had no allowances, and then they had to do redistribution, etc., etc. That was not a good planning. So in the beginning, we had the member states to distribute the allowances per sector, and then inside the sector per installation. Grandfathering was the method to free allocate from 2005 until 2012, phase 1 and phase 2. Here we have, of course, every sector to receive free allowances, even the power sector. And then we changed because we saw that something was not going well. I don't have the graphics that they show how many allowances were distributed, phase 1 and phase 2, and how many emissions we had, but the gap was huge. So you could see that we didn't define our way to distribute free allowances was not the best, because even the installations that for a reason did not produce, that means did not emit, they got the total amount of allowances based on their historical data. That was unfair for the installations, that because they had to produce more, they emitted more and they didn't have the time to decarbonize. Therefore, they needed more allowances. It was an unfair system. And then in phase 3, we introduced 2013, we introduced the benchmarking, which was a much better and fair way to distribute free allowances, plus one adjustment to the free allocation, which was something we called it partial cessation of operation, or also capacity extension or capacity reduction of the installation, because we had to take into account an installation that they invested to a new production line, and of course they should receive more allowances than before. That was capacity extension. So in 2013, the system started to be much more mature, I would say. Plus, I must not forget, all sectors received free allocation except for electricity sector, power plants. So there are as many emission allowances as the tons of CO2 of the cap, and here it is the total cap. A portion of them is allocated for free to the installations based on certain rules. 43% of the cap, it is distributed for free. The rest of them is auctioned, and free allocation is not a target. Let's not forget, I mentioned it in the first slide also, the free allocation is not a target for the installation, and it is not an emission limit. It is what they can receive based on the allocation rules. The calculation of free allocation is a whole chapter. An installation, well, when in order to monitor the emissions of an installation, we define in the monitoring plan the source streams. So we see where the stock is and where the emissions come from. And either we use a calculation method or a measurement method, etc. In order to calculate the free allocation, we have again to split the installation into theoretical, however, sub-installations. This is a theoretical part. I mean, for an engineer going in an installation, they cannot see how the installation can be split into sub-installations. However, if an installation produces a product that it is under product benchmark, then the whole installation produces one product that it is under product benchmark, then this installation will not be split into sub-installations. But if it produces two products that they have product benchmarks, then this installation is split into sub-installations. We have 52 product benchmarks and 2 fallback benchmarks. 2 fallback, it means that if we have an installation that produces, let me say, for example, tiles, that they are under product benchmark, and they produce also bricks, a specific product that it does not have product benchmark. Then this installation will have one product benchmark sub-installation and one fallback, which means that there we just measure calculate the emissions from consumption of fossil fuel or of the production of heat. Yes, let me. So the installation is split into sub-installations, and we have product benchmarks, as I said, 52, and then 2 fallback. It's the heat benchmark and the fuel benchmark. And then we had to introduce something more, the process emissions. It's not a benchmark, it's just the process emissions. Why? Because the process emissions are emissions that they are produced during a process based on the chemical reactions, and they cannot be there are techniques for the reduction of the process emissions, but this is another chapter. But if there are process emissions, then we just need to measure them. There is no benchmark for them. And we give free allocation to them like 97%, and it is going to be 91% in the next year. So no free allocation for electricity production, as I said, and emissions can only be covered by one methodology. One product, one benchmark. I will not go through this. I'm looking also at the time. And let's see how we calculate the free allocation. There is, of course, only one formula to calculate the free allocation. We calculate the free allocation per sub-installation, as I mentioned before. Let's keep an example in our mind. We have an installation that produces glass. For glass, there are 2 product benchmarks. One is for colored glass, and one is for colorless glass. And the reason is because the energy intensity is totally different for the production of the two types of glass. Therefore, we have 2 benchmarks. So here in this installation, for the F is for the calculation of the annually preliminary allocation for sub-installation, colored sub-installation. we multiply the benchmark value by the historical activity level. When we say activity level, we mean production. The historical production is based on 5 years medium on the median of the 5 previous years. And then we'll multiply it with the carbon leakage factor, if there is. Well, the production of glass is under carbon leakage, therefore the carbon leakage factor is 1. Now we have also a new factor in the formula, which is the CBAM factor. The installation of color, the installation that produces glass is not glass is not a CBAM product. Therefore, this factor also is 1. And then we calculate it with another factor if in the beginning of the allocation period, we saw that we should introduce a reduction factor, the cross-sectoral correction factor. I will not go to the linear reduction factor, is only for the new entrants. So you can see that there is for each sub-installation a formula that we have to, where we have to have the data in order to calculate the free allocation. And then in the next step, we do the same for the second sub-installation, third sub-installation, fourth sub-installation. It depends how many product benchmarks or fallbacks this installation has, and the total amount is the free allocation. Just keep in mind that the free allocation comes from the calculation, from multiplying the benchmark with the historical production. In simple words, I think this is just to keep in mind, and all the rest, they are details. At the moment, they are details because it's in the beginning. And here, I would like to show you schematically what it means, CBAM, the introduction of CBAM in our lives, and the introduction of CBAM for the free allocation. So there are some products that they are under CBAM, and these products, sub-installations that produce these products, they have to phase out free allocation with the same, following the same percentage as the CBAM is phasing in. Therefore, we start from 2026 with 2.5, I think, percent. And then we continue, and by 2034, the importers of the CBAM products, they have to pay 100% the carbon price, while the producers in the EU, they will receive 0 free allocation. This is something important because in some discussions I heard that there is a gap while our installations receive free allocation, installations that produce CBAM products receive free allocation, while the importers, they have to pay for the CBAM. No, it is not exactly this. Be careful. As much as they receive free allocation, so much they have to no, it's not so. 95% they receive free allocation. Our installations, 5% they have to contribute the importers and pay the carbon price in the border. So it is a very, very well addressed system, I think, to keep everybody, all the parties satisfied. And let's see what the benchmarking means. In EU, we decided to get the 10% best installations. Here in this sub-installation, in this product benchmark, we have 98 installations, sub-installations, that they produce, for example, color glass. Therefore, the 10% is 9.7. That means 10 installations. So we'll get here we have the intensity. That means the kilo CO2 that they emit for 1 ton of product. And then we get the 10%, the 10 best in the beginning, 10 installations, and we calculate the average, and we can see, we apply this, we call it as benchmark. And this is a white line. If we decided to get the average of all the installations in the same product benchmark, then it would be the red line. That means that we would give more free allocation, if you remember the formula. So the higher the benchmark, the higher the free allocation that they receive. We decided to have the 10% best, that means that they receive less. So only the installations that they are here in the beginning, you can say that if, I'll go back to the formula, if those installations, let's say that it is the best installation, they will receive the amount of allowances that they need. If they are not under, if they are under carbon leakage risk, if they are not CBAM products, and if there is not cross-sectoral correction factor, then this installation, the very first one, will receive enough allocation, free allocation, and they will also have a little bit of allowances that they will not need to surrender. Something like this. In reality, if they produce a little bit more, then they will have more emissions while the free allocation will be the same. Therefore, they will need to buy allowances. Reality is something different. Here is an example of a template to show you that it is why. The important thing is to remember that all the installations in EU, in all the states, they have to follow the same template, either developed from the EU or I think there is 1 or 2 member states that they developed a template by themselves, but then in the end they have to submit the data in the certain format. So it is homogenized, let's say, standardized, the way that we receive the data. Here I'm trying to explain what do we do after we calculate the benchmark, but I don't know if I have time.
Maybe just in a minute or two, if that's okay. We need to let
Yes.
everyone go for a break.
Okay, excellent. Then I will not mention what we do after the calculation of the benchmarks, because we need to compare them with the first benchmarks that we introduced in 2013. But I should mention something I think important. In the beginning of its allocation period, which is these years, it is like every 5 years. In the beginning, we calculate the free allocation for each installation. However, one installation may produce, as I said, more. In the past, they produced more or less, and they received just one certain number of free allowances. After many years, we saw that that was not fair, because there were installations that they changed their production. I mean, they used to have historical data, historical production based in one shift. And then they had more demand for their products, and they wanted to work the whole 24 hours per day. For those installations, they would receive the same free allocation, while their emissions would be at least double. So we saw that the system was not fair. And what we introduced adjustments to the free allocation. So every year we check the previous 2 years, the production. And if this production is more or less than 15% comparing to the historical production, then their free allocation is adjusted. And with this graph, we are just trying to show the historical activity level was based in, for the previous phase, 2014, 2018. That means we have a baseline period always 5 years. And then if there is more production, more activity level than more than 15%, then we adjust the free allocation. And the same if it is less than 15%, we adjust the free allocation. Every 5% intervals we do this. And this, you may think that it is complex. Yes, indeed, this may sound complex. However, in the beginning, when we calculated once the free allocation and we distributed the free allowances every year the same amount, we saw that this system was not fair for many installations. Therefore, we had to introduce something more. So you see, you start simple. As all the sites in the system, remember the institutional setup. We have the ministry, the competent authorities, the verifiers, the operators that they have the obligation. All these parties, they learn the system, they learn what their obligations, and since it starts running, then you will notice where there are points that you need to go deeper. So simply in the beginning, it becomes more sophisticated, I would say later, that means more fair. I don't like to say it more complex, but it looks like. And here I just put for you some examples on benchmarking. What does cement benchmark means? We define the system boundaries. They are very well explained in a guidance document, also in a regulation, in a secondary act, but then in a guidance document. And then we have frequently asked questions. So our engineers, installations, operators, verifiers, even competent authorities can find a reply to their questions. And here it is an example of the white cement clinker and the gray cement clinker, with some numbers. Thank you very much for your attention. I'll stop sharing now.
Thank you. Thank you, Irene, for the comprehensive presentation. Okay, is there any question from the audience? Okay, I have one question. Since the EU ETS cover both the electricity, the power sector and industry sector, so the emission from the generation of electricity is already charged the carbon pricing once, and if the industrial sector use the electricity, do they count those emissions in their from the electricity that they use as part of their emission? And if that's the case, would that particular amount of emission would be covered twice for the same?
No. Yes. Thank you for the question. No, definitely not. And please try, when you start developing your own ETS, do not have this overlap with carbon tax and ETS, because we hear it. And anyway, in our case, the installations that they used electricity, they didn't have to surrender allowances for the electricity they used.
Okay, so
but
they have to report it. So they have to report it, but when they surrender, they don't have to surrender for those parts. Is that correct?
Exactly. In the beginning, they didn't have to report. In the phase 1, phase 2 grandfathering, they didn't have to report how much electricity they used, because the electricity was already under the scope. So these emissions were already monitoring, reported, and under the compliance. The electricity generator had to surrender allowances for these emissions. So the industry that used electricity, they didn't have to report it, not even report. They just reported the emissions from their own use, their own production of heat. In phase 3, later though, we had to calculate the benchmarks. Then for the benchmarks, we needed all the data. And based on a template that we together with the member states developed, we asked them also to report how much electricity they used for the production of their product in order to have all the data there necessary for the calculation of the energy intensity and therefore the benchmarks, but not for the purpose of surrendering, because that would be clearly double counting and double surrender of allowances for these emissions. It is a crucial point. For us, we never had to surrender allowances for indirect emissions because they were already in the system.
Okay, thank you. So, ขอบคุณมาก So thank you very much, Irene, and let's give a round of applause for Irene. Thank you.